Cisco Certified Network Associate Day 20. Welcome back everybody, I'm Imran Rafa, your trainer for this entire series. Today we are going to look at static routing and we are going to get into routing topics now, and things are going to get very interesting from here on. So welcome, and let's get straight in without wasting much time. Alright, we'll start with looking at what we're going to cover today. We will cover static routing. We'll look how to configure static routing, and then we'll also look at what is the alternative that we have, right? So this is the topology we have for today. We have a computer which is with an IP address 192.168.1.10. This is connected through a switch to a gateway or router to his F0/0 interface, which has an IP address 192.168.1.1. The other interface, F0/1 of that router, is given an IP address 192.168.2.1, and that is connected to another router with an IP address 192.168.2.2. Right? That router in turn is connected to 192.168.3.2 and then connected to a 3.3 interface on another router. And the third router's other interface is connected to IP address 192.168.4.3, which is connected to a switch and then connected to another host with an IP address 192.168.4.10. Right? So if we know how to look at IP addresses, we see that we have one network here. So this is one network, that's a 192.168.1.0/24 network, and we are assuming this is all /24. And then we have the second network, 192.168.2.range. Then we have the third network, 192.168.3.range. And then we have the fourth network, 192.168.4.range, right? So we have four different networks. So if this computer wants to communicate with this computer, it looks at the IP address 192.168.4.10. That's what the IP address it wants to communicate. And knowing what we know and the way we have looked at data transmissions earlier, we know that this computer will have to send that data to its gateway, which is 192.168.1.1, this device. So it'll create what it has to create. It'll put the source IP address, destination IP address, source MAC address, destination MAC address, send that here. This device gets it. It looks at it strips the layer 2 information, that is the MAC address. It looks at layer 3 information, and it looks that the data is going to 192.168.4.10, and it says, okay, I'm not 4.10, so I see that this data is going through me, it's not to me. It looks at its routing table, and it says, if I have to route this packet to the 4. network, I need to send it to this device, 192.168.2.2, and it forwards that packet on this line. Similarly, this device looks at its MAC routing table, and it sees that if it has to go to the 4.0 network, it has to go through this and go to 3.3, and this device looks at its MAC routing table and sees that 4.0 network is connected to itself, and it gives that packet to this device, right? That's how we learned. Now, we did not discuss how the routing table is generated, right? So let's put this in Packet Tracer, and then we'll see how and what and how we develop this whole routing concept. Alright, I put the same diagram in Packet Tracer. So let's put the same IP address scheme. So I'm going to click here, IP address 192.168.1.10, 192.168.1.1, right? That's the gateway. So I think that information is enough here. This device, if I remember, it is 192.168.4.10, right? And IP address same, 192.168.4.1. Oh, was it 4.4? 4.4, I think. Uh, 4.3, 4.3, right? So 4.3 it is. So I'm going to change it to 4.3, right? So this is 4.3, right? So this is done. Right, so we'll not do anything with the switch. We're just gonna leave the switch because switch works without any configuration on that because everything is in VLAN 1. So we'll not do anything with switch. Switch is just going to be there. Alright, next we'll put um, the configurations on these devices. So let's go into the router, config terminal. First let's give it a host name R1, right? Interface F0/0, IP address 192.168.1.1 255.255.255.0, right? This is how you configure an IP address on the interface. And then we need to do no shut, right? And you see that this turned green. That means this interface just came up. We need to go give the same interface name to the other interface. So interface F0/1, IP address 192.168.2.1 255.255.255.0, no shut. Right, so this is simple things. We have not done anything new, so I'm just quickly rushing through this because it's just IP address configuration. And I will start putting the commands that we use in each videos in the description below. So you will start copying. You can start copying those commands from the description as well, right? I will try to zoom in so that you can even see it on your videos. But ideally, I think the right place to copy the configurations would be from the description, right? So we're done with this device. This is still not gone to green because this side is still not up, so there's no communication happening. So let's do that now. I'm gonna go into this router, configure terminal, host name R2, interface F0/0. Interface F0/0 is the one connected between here. So I'm gonna say IP address 192.168.2.2 255.255.255.0, no shut. Right, so this device come up, so you can see that these both are green. That means they already started communicating. Interface F0/1, that is the other end of the device, and I'm going to give IP address 192.168.3.2. 3 signifies this is how my naming convention is, 192.168, but particularly for this example, 192.168. Third, I've given the network ID. So here it is the 1.networks. In this case, I've done 2.network. Here I've done 3.network, right? And here I've done 4.network, right? And this is 192.168.1.1 and 1.2, 2.1. So basically, the last octet gave the router numbers. So this is 1.1 and this is 2.1. In this case, the router is router 2, so this will take last digits as 2, so it will be 192.168.2.2 and 3.2, right? So I gave 2.2 here, 2 being this octet 2, this network 2.0 network, this is 3.0 network. So 2.0 networks dot 2 I've given to the router 2's interface, 3.networks dot 2 I've given to the router 2 interface. Yeah, see what it is? Yeah. So IP address I've given, no shutdown. This is done. Now I'm gonna give that same thing here. Enter, configure terminal. Host name R3, router 3, interface F0/0. That is this interface F0/0, right? And I'm gonna give, if you follow the same convention, 192.168, this is the third network, so 192.168.3 dot, this was 3.2 because this is router 2, and this is router 3, so it is 3.3, right? So I'm going to give 3.3, 192.168, IP address 192.168.3.3 255.255.255.0, no shut. And you see both of them are up. I'm going to go to the next interface, that is interface F0/1, IP address 192.168.4.3 because it's the fourth network, and the router is 3. Right, this is just convention. I've done this so that it's easy for me to remember, but there's nothing like but router 3 has to always have an IP address 3. No, in when you're designing a router, it's always about conventions, and conventions, if you follow, stick to a certain convention, everybody will have a convention. You can have your own convention, or your company will have a certain convention that they follow. So if you're in a company, it's ideal that you follow the company's convention, because everybody in the company would be following that, and it becomes easy for each other, right? So if you configure something, a colleague of yours come, it's easy for him to troubleshoot because he knows what the company's convention is, right? Right, so it's all convention. It's up to you. You can do anything you want. You can give any IP address, right? So again, 192.168.4.3, this interface. So this interface is 4.3. I'm going to give 255.255.255.0, no shut. This interface has come up, and because this is a switch, they will automatically start communicating, right? So I think we are good everywhere, right? So now let's start. Let's go to a command prompt, and I want to ping this device. Ping 192.168.4.10, right? I've given both the PCs ending with 10. So this is 192.168.1.10, 10 for PC. So it's just a convention that I'm following. 192.168.4.10, right? So I'm going to ping from here, this computer. I'm going to ping to 4.10, and let's see what happens. So I ping this. Let's go into simulation mode. So capture and forward packets. Okay, PC1 STP. I think we just lost it. So let me do that again. Where is that? It's here. I'm gonna ping, and let's see what happens. It sends an ICMP. An ICMP is ping. It's Internet Control Message Protocol, ICMP. So when you do ping, so ping is a protocol that we use to do connectivity testing, right? So when you can send a message from one device to another device, and if that device receives the ping packet, it will send a reply back saying the ping reply, right? So when it receives that reply back, you know that the connectivity is there between those two devices. So now I have sent a packet. That packet has reached here, ICMP. This so according to what we already know, this packet, let's look at this. So it says it's 192.168.1.0. It is going to 1.10 going to 4.10 ICMP message header, right? It's an outbound. So you'll look at all these preambles and the headers and the frame formats. We did this in OSI model. So it goes down, it comes to the switch. The switch looks at it. It says, okay, it needs to go to the MAC address. So it sends to the MAC address. So let's send it next. So that packet goes. The switch sends it to the router. The router looks at it. Router sees that it has to go to 192.168.4.0, and it drops there. Why does it drop there? It drops it there because it doesn't know where 192.168.4.0. Now how did that decide that? So let's see what happens on the command prompt. So you see, let's make it in real time. You will see that it says reply received for 192.168.1.1. 1.1 is router 1. This device is sending a reply back to this PC saying destination host unreachable. So what happens is, this is router 1. So I'm going to go here, show IP route. Now this is the most critical table, and this is the most critical troubleshooting command that you would do in Cisco routing. Show IP route. Now this is a routing table. So at the moment there are two entries, right? This is just codes for you to identify what does these alphabets say. So it says C, and C is directly connected. So we can see that 192.168.1.0/24 is directly connected on fast Ethernet 0/0, and 192.168.2.0 is directly connected on fast Ethernet 0/1. So at the moment he knows only these two networks, 192.168.1.0 network and 192.168.2.0 network. Now take a small break. Look at this. These are the network ID. So when we did subnetting, we did a lot of network ID, network ID, network ID, network ID. This is where network ID is there. So this network ID tells this device that all the IP addresses in this network, right, 192.168.1.0, that means from 1.1, what are the valid IP addresses for this network now? If you do it's a /24, that means there are 254. That is 192.168.1.1 till 192.168.1.254. These are valid IP addresses. So any IP addresses in that range is reachable, or technically it should be reachable, because this device is connected to that network. Remember, one router can be connected, each of those interfaces should be connected to one network. So when it sees that it is connected to a /24 IP address, it knows that the whole 254 IP address should be connected in that. So it will just send it there, it'll send a broadcast in that network, right? So 192.168.1.0 and 2.0 is connected to this device. So this device knows only about that. Now when ping or ICMP packet reaches there, it does not have a way, it does not know that 192.168.4.0 is available on this route, right? So as a network administrator, you know that it is available by sending that packet to this device. So let's do this. Let's create a static route on this. We'll tell this device that whenever he gets any packet or any traffic for 192.168.4.0/24 network, please send it to this device, router 2. How do we do that? So the format for static route is this: IP route, then give the network ID, then give the mask, and then you need to give the next hop IP address, or you need to give a exit interface. What do I mean? Wait a minute, I'll show it to you. So I'm going to go here, and routing is done on the global configuration mode, and this is static routing. If you want to do dynamic routing, that is done in their own sub configuration modes, right? So at the moment it's global configuration mode. I will type IP route, right? And what is that network we need to look at? 192.168.4.0 network. At what subnet mask? 255.255.255.0. This means that it's 192.168.4.0/24. That means any traffic for 192.168.4.1 to 4.254, this applies, right? This rule applies to all the traffic in that range. So I'm going to say any traffic that is, I'm going to tell this router. Now we're telling router 1, right? Router 1, we are telling that any traffic going to 192.168.4.0/24, please send it, please forward that to 192.168.2.2, which is this interface, right? So I'm going to say that 192. So let's look at this. Let's put the question mark and see what are the available commands. So I can give an IP address, or I can give an interface. So I could very well say give it out on fast Ethernet 0/1, which is this interface. I'm going to say that send the traffic out on this. Doesn't matter what it is, just send the packet out on this. Or I can tell send that traffic to the next hop interface IP address. So next hop IP address is 192.168.2.2. Now the question should be, which is the best? Both are really good, but ideally on a broadcast network like Ethernet, it is best to use the next hop IP address. But if you're using, let's say, like point-to-point networks like frame relay, in that case, you could use the exit interface, right? We will look at frame relay much later, but at the moment, use this. Put the next hop IP address. That is the best, right? So I'm going to put this 192.168.2.2, right? So now let's go look at the routing table. So do show IP route. You will see that this routing table got a new entry, and it says S. What does S mean? So if you look at this legend here, you see S stands for, where's S? Yeah, S stands for static, right? And it says 192.168.4.0, please send it to 192.168.2.2. Now let's go back to our ping command prompt. I'm going to do the same ping. Now the packet should come all the way here, and the traffic should go to this device, and this device should drop it, right? Now look at it. Now this device has to send the packet back to 192.168, right? So this is how ICMP works. Whenever it has any error, like in case it doesn't know, like if you look at this message, it said destination host unreachable. How did it know? Because it was a reply that it got from 192.168.1.1. So this device knew how to send that message back to this device, saying, you know what, I couldn't find that destination. But now the packet has left here and it's gone to router 2. Now router 2 looks at that information. It says, okay, you're trying to go to 192.168.4 dot network, and let's look at the routing table of this device. And it says, I know only 2.0 and 3.0. There is no way I know anything about 4.0. So I'm gonna say destination host unreachable. So it says it says it wants to send the destination host unreachable message, but it doesn't know how to even reach back to you, because this device is 192.168.1.0, and like we just looked at it, it doesn't even know anything about 1.0. So there's no way it could inform the sending device that it cannot reach the destination device. That is why we have this message which says request timed out. If so, in IP networks there is a TTL value. So it has a TTL value 16, 255. Different devices have different TTL values. So if it doesn't, if an IP packet goes that TTL value, so if it says every time it goes a hop, it reduces the count. So if it's starting with 16, one hop it becomes TTL 15, one hop it becomes TTL 14, another hop TTL 13. It goes till TTL becomes 0. Once TTL becomes 0, it kills itself. This is a loop prevention mechanism in IP packets, layer 3 packets. It does not want to create loops, so it kills itself when the TTL becomes 0. Now, every time ICMP is sent out, the sending device has a timer. It looks at a certain time, it waits for a certain time. If it doesn't get a reply in that time, a request timed out message is shown, right? So now let's do this. Let's go to router 2 and tell it how to reach the 4.0 network. So it says, so let's say IP route 192.168.4.0 255.255.255.0. Please go to 192.168 3.3, if I'm not mistaken. 3.3, yeah, 3.3. Right. So do show IP route. I know how to go to 4.0, right? So now if I do this, what will happen? Will it reach? Right? So now this device knows how to reach 4.0. Let's look at this device. So router 3, do show IP route. Router 3 knows 3.0 network and 4.0 network. So now when the packet reaches here, it says please go to router 2. Router 2, it says please go to router 3. And router 3 is already connected to 4.0, so it can definitely reach this device. So think about this. What will happen if I ping again, right? Because all the intermediate device now knows how to reach for the 4.0 network, and specifically how it knows how to reach the 4.10 host, right? That is this computer. But will it ping? Right, if you said no, you're absolutely right. So what happened? So if you look at ICMP, like I said, ICMP is it's a protocol where it works with two-way communication. So you send a message, it needs to get a reply back. And that's how routing is. If you want to have a route between two devices, you need to have routes on either way. That means you need to tell all the devices in between how to go in one direction, also you need to tell those devices how to come back. So now when those packets come, it reaches this packet, this PC, or the 4.10 host. This host says, fine, thank you, I received it, I'm going to send you a reply. So it sends an ICMP reply message. This device gets it. On the way back, now the destination is 192.168.1.10. So router 3 looks at it and says, okay, you want to go to 192.168.1.10, but I only know 3.0 and 4.0. I don't know anything about 1.0. So we need to create a 1.0. So I'm going to say IP route 192.168 1.0 255.255.255.0, go to 192.168 3.2, right? So this device, I'm going to send it to this device. This is network 3. Network 3 is router 2, 3.2, right? Now what will happen? Same thing. This device will say, okay, I know 3, 2, 3, and 4, but I don't know where 1.0 network is. So I'm going to say IP route 192.168 1.0 255.255.255.0, send it to 192.168 network 2 router 1, right? And that will come here, and this device already knows about 1.0 because it's directly connected to 1.0, and technically it should communicate. Now, one question. It only knows 1 dot, 2 dot, and 4 dot. It doesn't know about 3 dot network. Similarly, this device knows only about 1 dot, 3 dot, and 4 dot. It doesn't know 2 dot. So this device, router 1, does not know about network 3, and router 3 does not know about network 2. Will that be a problem? Because that's an intermediate network that it doesn't know. Let's see. So I'm going to ping again, and if you see, the reply is coming. So the message is going all the way to this device, and this device is replying, and that reply message is coming back, and that's why it says reply from 192.168.4.10 with byte size of 32. TTL is, or time it taken is 0 millisecond. TTL is 125. I told you the TTL value. And this is 100% success. That means it is receiving the reply back. So even if it doesn't know some of the networks in between, it doesn't matter. It only looks end to end. That means this device needs to know how to reach the end, that is 4.0, and this device needs to know how to reach the 1.0 network. If this device was sending a traffic to, let's say, in between, let's say now, okay, let's look at that. Now, this device, PC1, let's call it PC1, is successfully being able to communicate to PC2, which is here, right? It is going through all these devices. Now, let's look at this. Can this PC ping to 192.168, let's say this device, router 3's interface 1. So, let's say 3.3, that is this interface, F0/0 of router 3. Can it ping? You remember, it just went through that device, through that interface to reach PC 2 at 4.10, this one. It went through this device to reach here. But we are now checking if it can reach this device, this interface, which is actually something it went through, right? It will not reach. Why? Because when you send that traffic to router 1 will look at its routing table, and it says, you're trying to reach to 3.0 network, but I only know 4.0 network, and then the two connected interfaces, 1.0 and 2.0. I know nothing about 3.0. So if you want to have communication to 3.0, you need to put the same static routes for 3.0. Right. So can you see how cumbersome it is to create static routes? You have to individually create static routes for everything. Now just 3 routers. If you have like 10 routers and you have, let's say, 50 different subnets, you need to create that many static routes to do just end-to-end communication. To solve this is why we need dynamic routing. So I'm going to quickly do this. I'm going to remove all the routes that we just created. I'm going to say no IP route whatever 4.0 I removed from here. Here there are two or rather, yeah, we have do show IP route. So there are two static routes that we created. So I'm going to remove both those static routes. No, if you remember how to negate commands, it is just no. Okay, I'm going to remove 1.0. I'm going to remove the 4.0 route. I'm just going to say, right, if you do Control A from end of a, let's say from here, I'm at the end. If you see my cursor is at end, I do Control A, it jumps to the start, and I'm going to say no, and I hit enter, it removes. So if I say do show IP route now, it is removed. Similarly, I'm going to do that here. I'm going to say no. So what I've technically done now is do show IP route. I have removed the static route that we did. I have removed the static route that we did in router 2, and I have removed the static route that we had in router 1. So right, so there's no static route. So let's look at IP dynamic routing. So I'm going to enable RIP. RIP is very fast. This video is not about RIP. This video is only about static route, and we saw how tedious static route is. But I'm going to show you a quick demo about RIP. RIP we're going to look at in depth in the next video, but this is just for demonstration. So don't worry, how I'm just quickly going to run through it. I will come back to how to configuring this in the next video, so don't worry, just look at the magic, right? So I'm saying router RIP version 2. I'm going to say network 192.168.1.0, network 192.168.2.0, done. I'll come here, I'm going to say router RIP version 2, network 192. So what I'm technically doing is I'm just typing in the network that it is connected to. So this device is connected to 1.0 and 2.0. This is connected to 2.0 and 3.0. So I'm just going to say network 192.168.2.0, network 192.168.3.0. These are the two networks that it is connected to, right? So I'm going to come here, 3.0. Similarly, router RIP version 2, network 192.168.3.0, network 168.4.0, and boom, magic should be done. I'm going to go here, I'm going to do the same thing, do show IP route, boom, look at it. Again here, do show IP route, boom, and do show IP route, boom. See, so these two are connected. We knew this already. Now you see R is RIP. Can you see RIP? R is RIP. It learned about 3.0 and 4.0. I just put two commands. That's it. Now, as long as RIP is running, and if I add another router and that had, let's say, 5.0 and 6.0, and I enable RIP on that device, those devices using RIP, it will start communicating with each other, and all these devices will know about those 5.network and 6.network. I don't need to do anything more on these devices. That is the power of dynamic routing. So if we do this ping now, 4.10, it will work, absolutely no problem. And if you try the one that failed earlier, 3.3, that will also work because it knows how to reach 3.3. And all the devices know about all the networks now. So like I said, router 1 knows about it, router 2 knows about all the network, and router 3 also knows all the network, right? If you can see here, it learned, this also learned. So this is the beauty of dynamic routing, and we will have a look. I mean, I'm not saying RIP is the best, but there are so many things that RIP does so effortlessly, and it's so easy to learn. but there are so many drawbacks in RIP, but we will look at all that. So at the moment, just try to understand what routing is and how routing works. What is a routing table? What is the significance of a routing table? So basically a routing protocol, whether it is you're doing it static routing or dynamic routing, the role of these routing protocol is to fill this table. This table needs to know all the routes, all the networks, route information to reach those routes by the traffic, right? So this is the gist of routing, right? So that's what routing is, and the easier way, like we discussed, is the dynamic routing. So we will look at dynamic routing. We'll start with the RIP in the next video, but the takeaway from this video should be what routing is. Routing is a process by which you fill those routing tables so that the router can make routing decisions for traffic to reach anywhere in the network, right? So it's been a pleasure. I'm trying to give more and more time to this series, so I'm going to have more and more videos coming soon. All I ask from you is watch these videos on YouTube, subscribe to the channel, please share it with your friends, get more and more of your friends to come and watch it on YouTube, get more and more of your friends to like the videos, you yourself like the videos, like us on Facebook, give us some thumbs ups, give us some good comments, give us reviews on Facebook, subscribe. This is something you can do for us, right? We're not asking you for any money, we are asking you for your support. Just support us. Let's make technical education more easily accessible to people who cannot and would not want to pay a lot of money, right? There are a lot of free, I'm not saying there are a lot of free channels on YouTube, but what we are trying to achieve is to give quality education, which I really don't think so there is any way we could put a price on it. We want to give quality education. We're not looking at the money aspect, we're not looking at the financial aspects. We want to revolutionize this education industry. All we need from you is your support, your love, and your prayers, right? So thank you so much. I'm gonna join you very soon in the very next video, so stay tuned, and thank you once again. Bye bye.